Hi everyone, I'm CHIKA K Gangadharan, Assistant Professor, Department of Electronics, MES College, Marampally. I'm going to give a short comparison between nMOS and pMOS transistors. That is how we can turn on and turn off this pMOS and nMOS transistors based on the threshold voltage applied across the terminals. Field effect transistors are depletion mode can be divided into depletion mode transistors and enhancement mode transistors corresponding to whether the transistor is in an on state or an off state at zero gate source voltage. These enhancement mode transistors are mainly used as switching elements in integrated circuits. These devices are off at zero gate source voltage. In nMOS transistors, it can be turned on by pulling the gate voltage higher than the source voltage. pMOS transistors can be turned on by pulling the gate voltage lower than the source voltage. In most circuits, this means pulling an enhancement mode MOSFET gate voltage towards its drain voltage to make it turn on. In depletion mode transistors, the devices are normally on at zero gate source voltage. These devices are commonly used as load resistors in logic circuits. For n-type depletion transistors, the threshold voltage must be about minus 3 volt, so it could be turned off by pulling a gate voltage having a voltage negative 3 volt. In case of pMOS transistors, the polarities will be reversed. That means we have to apply a positive voltage to positive 3 voltage to make it turn off. The mode of these transistors can be determined by the sign of the threshold voltage applied across the gate terminals. For n-type FET, enhancement mode devices have positive threshold, and in depletion mode transistors, the devices we have negative threshold. For a p-type FET, the enhancement mode we have to apply a negative threshold, and for a depletion mode transistors we have to apply a positive threshold. Now we can look into the table that gives the key voltage or the key threshold voltage applied across the terminals so as to make it turn on and turn off. We can compare pMOS and nMOS transistors as well as enhancement and depletion mode transistors. First we can look into enhancement mode nMOS transistors. The initial condition should be Vd must be greater than Vs. That means we have to apply a drain voltage greater than source voltage. And to turn on this enhancement mode nMOS transistors, we have to apply a gate voltage greater than or equal to Vs plus 3 volt. This will turn on the enhancement mode nMOS transistors. And to turn off these transistors, we have to apply a voltage that is gate voltage less than or equal to Vs. While considering the depletion mode nMOS transistors, the initial condition is same as that of enhancement mode transistors, that is Vd should be greater than Vs. And to turn on this depletion mode nMOS transistors, we have to apply a gate voltage greater than or equal to Vs, and to turn off these transistors, we have to apply a gate voltage less than or equal to Vs minus 3 volt. Now we can see the working of a pMOS transistors. While considering a pMOS enhancement mode transistors, the initial condition should be VD, that is, drain voltage must be less than source voltage. And to turn on the enhancement mode pMOS transistors, the gate voltage should be less than or equal to Vs minus 3 volt. And to turn off this enhancement mode pMOS transistors, we have to apply a gate voltage greater than or equal to Vs. In case of depletion mode and pMOS transistors, the initial condition is same as that of enhancement mode transistors, that is, drain voltage should be less than Vs, and to turn off this turn on these transistors, we have to apply a gate voltage less than or equal to Vs, and to turn off this depletion mode pMOS transistors, we have to apply a gate voltage greater than or equal to Vs plus 3 volt. This is a short comparison of pMOS and nMOS transistors, how we can turn on and turn off these transistors based on the threshold voltage applied across the terminals. Thank you.